So we know that we need to, in order to determine if this series converges or diverges, we know that we need to find the limit as n goes to infinity of the sequence of the partial sums. All right, so that's going to determine whether our series converges or diverges. So let's start off with listing our terms. So our terms, the terms of the series, so let's see here. So terms of the series, we can just go ahead and give a formula. A sub n is going to be 9 over 10 to the n, right? Because remember, the terms are these little numbers right here out in front. Now, once we have the terms of the series, we can talk about the terms of the sequence of partial sums. So the terms of the sequence of partial sums. Another way to say this is the partial sums, right? What are the partial sums? Now, the formula for Sn is supposed to be what happens, or what's the result of adding up the first n terms of your series, right? So for us, we'll have, so let's see here. We're going to need to find a pattern. So S1, well, let's see here. So S1 is going to be A1. S2 is going to be A1 plus A2. S3 is going to be A1 plus A2 plus A3. S4 is A1 plus A2 plus A3 plus A4. And from there, I should be able to figure out a formula for Sn, A1 plus A2, adding all the way up to A sub n. Now, let me go back and actually write a few of my terms. Now, A sub n is 9 over 10 to the n. So, S1 should be equal to just 9 over 10. And this is what I get when I plug in n equals 1. Because let me actually see here, this might be helpful. A1, make this a little smaller. So A1 is 9 over 10. A2, 9 over 100. A3, 9 over 1,000. A4, 9 over 10 to the fourth power, dot, dot, dot. So now when I come down here, A1 is just 9 over 10. A2 is 9 over 10 plus 9 over 100. And remember, we said that this is going to be the same thing as 99 over 100, which is going to be 0.99. S3 is going to be 9 over 10 plus 9 over 100 plus 9 over 1,000, which is going to be 999 over 1,000, 0.999. So notice if we were to compare, S2 is 0.990, S3 is 0.999, S4 is going to be 0.9999, and Sn, what is Sn going to be? Well, Sn is going to be 0.99, right? And I know that I'm going to have 9 or n nines. Here's the problem with writing it like this. It's going to be difficult for us to figure out what the limit is or to compute the limit. So I need to rewrite this as, so this is going to be, I know the denominator is going to be 10 to the n, and the numerator is actually going to be 10 to the n minus 1. So do you see here? This is the same thing as 10 to the denominator is 10 to the fourth power. And so let me make sure 10, 2, 3, 4, yes. 10 to the fourth power minus 1, right? This is 10 cubed minus 1 over 10 cubed. This is 10 squared minus 1 over 10 squared. And this is 10 minus 1 over 10. Now, I know how to take the limit as n approaches infinity of this, right? I don't have any limit laws to work with the left-hand side because writing dot, dot, dot is not precise. If I write 10 to the n minus 1 over 10 to the n, this is very precise, right? So I've got my Sn, and my formula for Sn that I'm going to use is Sn equals 10 to the n minus 1 divided by 10 to the n. Now, when I go up here and I say, what is the limit as n approaches infinity of Sn? I'll say, oh, okay, I know that. That's the limit as n approaches infinity, 10 to the n minus 1 over 10 to the n. How do I find this out? The numerator is going to plus infinity. The denominator is going to plus infinity, right? So we could use L'Hopital's rule. You could also just rewrite the function or the terms. So if we rewrite it by just dividing, I'll get 1 minus 1 over 10 to the n over 1. You see I just multiply the top and the bottom by 1 over 10 to the n. Right, so then the 10 to the n cancels out and I get a 1 in the denominator and 1 minus 1 over 10 to the n in the numerator. And now I can use my limit laws to say that this is going to go to 0, right? 1 over 10 to the n goes to 0. So this entire limit is equal to 1. So now I say, aha, in conclusion, right? This sum, 9 over 10 to the n starts at 1, is equal to 1 because it's equal to the limit, right? It's equal to the limit of Sn, and we found a formula for Sn by recognizing the pattern. So this limit is equal to 1. And now remember, what is this? This is the mathematical way to write 0.9 0.9 repeating. So we've proven that 0.9 repeating really is 1. It's not a different number from 1. It is 1. It's a limit, right? So this 0.9 repeating is a limit. It's a fancy way to write 1. That's it.